Welcome back. In the previous lectures, we talk about the course content and importance of the seismicity and how we will identify the paleo earthquakes and which are the regions. So, in this lecture, let's move ahead and see what important points we need to understand and we need to learn. Is most important is the distribution of oceanic and continental plates, because these are the regions or the locations which are producing the earthquakes on the Earth's surface or Earth interior. So, just in giving a glimpse of the landscape across the globe, we have different plates here. That details we will talk when we are talking about the plate tectonics part, but this is what is the configuration of different plates with respect to one another. So, for example, we are having the Indian plate which is sitting here, a very small one as compared to what we are having the African plate and the South American plate, or we can say the North American plate. We have a smaller one here, and then we have this orangish color or dark color features which are the landforms. Okay. So, these are the Himalayas which we are having, and we have another one is the subduction zone which is existing here as well as over here also. This is Makran zone. So, distribution of the oceanic plates. So, these are all oceanic plates, but we are having, so either they are subducting with respect to one another. So, we have this as continental plate subducted below the continental plate, but now it is colliding. Okay. But initially it subducted because we had an ocean plate in front of the Indian continental plate. And for example, over here we have this configuration where the oceanic plate is subducting below the continental plate, and these are the landforms or the mountain chains which have been developed because of, or we can say that this is the manifestation of the deformation between the Nazca plate. There is an oceanic plate subducting below the South American plate. So, this all we will discuss when we are talking about the plate tectonics in a brief way, and then you will learn more about that. But these are the locations which are the locations where we expect the large magnitude earthquakes in the region. So, we have the distribution of the oceanic and continental plates, and we also understand that the plates are either subducting with respect to one another, or they are sliding pass away with respect to one another. For example, here the Pacific plate is moving in this direction as well as it is subducting, and the North American plate is moving in this direction. Okay. So, and here also the arrows which are been showing is are shown the arrows are indicating the direction of the movement of the plates. Okay. And then either we are having the subduction zones or not. This details we will talk about when we are talking about more on the plate tectonics part. But the important point here which I would like to mention is that these are the locations where you will expect the large magnitude and mega earthquakes, as well as in this region which is the part of the India, we will expect the large magnitude and mega earthquakes in the region. So, how often do earthquake occur around the globe? So, this will be the basic question which should come in our mind, that how often. So, we will keep talking about small magnitude earthquakes, large magnitude earthquakes, mega earthquakes or great earthquakes, but how often those earthquakes are occurring. And I would like to emphasize here is that the when we talk about the magnitude, in terms of the magnitude, magnitude is associated with the amount of energy which has been released, and this energy is, we would talk about the strain which has been accumulated over the time because of the ongoing deformation. So, if you talk about 1 magnitude and if you go to second or 2 magnitude, then the difference is in terms of the energy is almost 30 times more. So, if we say that, okay, 8 magnitude earthquakes in Himalayas are likely to occur, and then how many small magnitude earthquakes or moderate magnitude earthquakes will suffice that amount of energy, which will be much larger. So, large number of earthquakes will be required of moderate magnitude or small magnitude to suffice one single 8 magnitude earthquake. So, Earth, as we know, is a very dynamic planet, and one of the it is active region. So, Earth comprises several active tectonic boundaries which are between the tectonic plates or lithospheric plates. Hence, earthquakes always are occurring somewhere on the Earth because of the ongoing deformation, because these plates are moving with a particular speed with respect to one another. So, the National Earthquake Information Center, NEIC, locates about 12,000 to 14,000 earthquakes of different magnitude each year. On an average, earthquake with magnitude less than or equal to 2 occurs several hundred times a day worldwide. So, this shows that the Earth is quite active. We may not be able to notice or experience the 2 magnitude earthquake, but the seismometers will record this, and this shows that there is some movement which is going on beneath the Earth and along the plate boundaries. Further, if you look at the major earthquakes with magnitude greater than 7 occurs more than once per month. So, it is this planet is not quiet, it keeps on triggering earthquakes. And if you talk about the great earthquakes which are having the magnitudes greater than or equal to 8, they occur once a year around the globe. So, we do not know that when such large great earthquake will occur in Himalayas, but I would say that with the help of the paleoseismological studies and the GPS measurements, to some extent we understand that which are the locations which have accumulated the strain over the time or energy over the time and are likely to trigger such great earthquakes, and in particularly in Himalayas. Now, coming to some terminologies which are going to be important for us as active tectonics. So, these are what we are talking about, the tectonic movements. So, active tectonics in earth sciences, the term tectonics is referred to the processes, structures, and C, the landforms associated with the deformation of the earth crust. So, what are the processes which are involved? So, this part we can talk when we are talking about the interior of earth to some extent, as well as the seismic waves and plate tectonics, and what type of structures we see as in case of the manifestation on the earth's surface, and those are the landforms which are associated with the ongoing deformation. Then tectonics refer to the evolution of these structures and landforms over the time span. So, for example, as I told about that Himalayas is a result of the ongoing tectonic deformation. So, we have higher Himalayas, we have lesser Himalayas, we have sub Himalayas, or we say Shivaliks. So, in terms of the elevation also, if you see, the higher Himalayas are having the elevation more than 6,000 meters, and then coming down we have around 5,000 or 4,000, and then to 2,000 or 1,000 meters. So, these are the different ranges which were developed over the large span of time, and these are the results of the ongoing deformation. So, the tectonic deformation is referred to the evolution of the structures, okay, and associated landforms. Further, on a global scale, we are concerned with the origin of continents and ocean basins, which are the largest landforms produced by tectonics on Earth. So, what we were looking at, the distribution of the lithospheric plate, either it is a continental plate or an oceanic plate, they have resulted into the formation of different landforms, either they are the elevated portions or they are having depressions. So, we talk about the basins. Okay. Now, these are all on the global scale, but coming to the regional scale, we are interested in structures that produce mountain chains. On the larger scale, we are talking about the ocean basins and mountains or the continents, either it is oceanic or the continental plates, but on regional scale, when then we come down to talking about that how this deformation is responsible for developing or producing the mountain chain. Then comes down to the local scale. We often study features such as small folds. These are all structural features, geological structures, folds, which may form elongated low hills or faulting. So, what I would like to emphasize here is that we are coming from the global scale. We are talking about coming to the narrowing down to the local scale. Okay. So, coming to the particular site. So, we talk in the broader sense that how this all plates or the continents are distributed, and then what are the associated deformation and what are those the large scale features, narrowing down to a particular region. Okay. So, this is what we see is on the local scale, and local scale which may result in surface ruptures and the production of relative small, a few tens to hundreds or thousands of meters long by less than 1 meter to about 8 meter high scarps, and this scarps or the deformations are termed as fault scarps. So, one sketch which I drew in the previous lecture about the fault scarp. So, particularly these are the features which we will talk when we are talking about the local scale. So, any study we start in the paleoseismological studies, basically we look at that what is the global tectonic framework, then we come down to the local and the regional one. Okay. So, this part will remain almost common for all such type of studies. So, we see what type of deformation is taking place on the global scale and the regional scale and then the local scale, and what are the associated features. So, we say on the larger global scale, we talk about the plate tectonics, the either subduction zones or the collision zones. Then we are coming down to the regional scales, we talk about the development of the mountain chains and all that, and further local scale we talk about the smaller features like fault, folds, joints. Okay. And mostly the surface ruptures, that is the fracturing or the displacement which we will observe on the surface will be manifested in form of the fault scarps. Okay. So, if we talk about the like I will again draw and sketch here. So, we have the layers here, and then if you deform in terms of the compressional tectonic regime, then what you will see is the a deformation like this. Okay. So, these are the fault scarps. Okay. What you will be able to observe on the surface. Okay. So, this I have drawn the section. So, further, earthquakes and its impact. Okay. If you take, okay. So this is a tagline which talks about that earthquakes never kills the people, but the buildings do. So, most of the people will be killed during an earthquake because of the damage. So, it is very important and significant for us to locate such locations or the regions, okay, which are likely to produce earthquakes in near future. Okay. And what will be the magnitude? This will be the question. How far we are, that is the site, from such regions. So, for example, if you say that, okay, fine, this is what you have the Himalayan range, then how far you are sitting from Himalayas. So, this will be extremely important. If you are sitting here, then of course, and then you are having the subduction zone. So, depending on that how far you are sitting, whether you are close to the deformational area or the deformational zone, that is also going to bother you. But even if you are sitting away from such regions, one should definitely take into consideration that what will be the magnitude of earthquake. So, earthquakes never kills the people, but the buildings do. So, this information will help basically the town planners or urban development to take into consideration that what effect they will have, okay, on a particular site because of strong seismic shaking. So, these are few important points which we should keep in mind when we are moving ahead in this course. Okay. So, for example, as I told that earthquake never kills people, but building do. These are few examples which I am highlighting here. This is the earthquake damage which occurred in Los Angeles in 1994. Then coming to 1985, Mexican earthquake, the pattern of damage you can see. So, basically what we are looking is the poor construction without having a proper understanding that what will be the amount of or the intensity of ground shaking by a particular earthquake in that region. So, this lack of knowledge, whether it existed before, the answer is to some extent yes, because the earthquakes occur or the recurrence of the earthquakes, such earthquakes, are more than 400 or 500 years. So people tend to forget very fast. But which fault or which area is due in producing the earthquake in that cycle? So you may have number of earthquakes in a gap of 50 years or 40 years or 100 years. So once you say that, oh, you told that it is the recurrence is 500 years, so no earthquake is going to occur in 500 years. But no, which area, the different areas will have the different recurrence interval. So different fault lines may have the probability of triggering the earthquakes at different point of time. Now the best example which I can highlight here is that in 20th century we had experienced 3 major large magnitude earthquakes in Himalayas, and those were 1905 Kangra earthquake with magnitude 7.8. Then we had 1934 Bihar Nepal earthquake with magnitude 8.5 to 8.3 to 8.5, and then around 8.4 was 1950 Assam earthquake. So in just a time span of 50 years we had these 3 mega earthquakes, or we can say not mega but large magnitude earthquakes, of course. So we need to be prepared for this. Okay. 1995 earthquake damage in Kobe. Now these are the regions which I am talking, which are very prone or extremely prone to earthquakes. So whether Japan was not ready for such a damage, the answer is yes. But after 1995 they have done extensive studies to identify such fault lines or the regions or the areas where the likelihood of future earthquake is certain. I'll give a small lecture on particularly the damage pattern, not only the damage pattern, but we will talk about the rupture pattern, surface rupture or surface manifestation, which was by 1995 Kobe earthquake in one of the lecture. But here if you see, this is the damage pattern, one of the express highway and the flyover which was toppled down because of the strong ground shaking. Rupture was far away. This was in Kobe, and this is far away from Kobe where the surface rupture took place. So this is what they have done as a wonderful way to reach the local people or the citizens of that country and make them understand that what exactly happens during an earthquake. So this is a section which you see the line here. This is a fault plane along which this block of the rock block or of the surface has been risen or moved up. Okay. So I am not going into the detail of this, but we will talk about this. These are typically faults. Okay, and this manifestation which you see is the fault scarp. So they have preserved this and created a museum to reach people or the local citizens. So this is what they are having, the outreach programs. But in India we have not done this because the last earthquake, the major one which we experienced with such deformation was or were in 20th century. But we have been able to identify the rupture of 1905 Kangra earthquake in Kangra Valley. I'll give a lecture on that also. Okay. So you will understand that what we are talking about, the fault scarps, what we are talking about, the faults and all that. But in short, as we have been talking about the tagline that the earthquake never kills people but building do. So this is the pattern of damage which was experienced in 1995 Kobe earthquake, and this example, it shows that how the deformation is manifested on the surface. So, movement along this one, this is a section, and the surface manifestation, there is a scarp. So, this block has moved up here as compared to this one. Then this was 1999 Chichi earthquake in Taiwan, which shows the fault scarp here. Okay. So, this was the deformation was manifested, or the manifestation was seen and passing through one of the pavilion and the running track, which got displaced and deformed. Okay. Then the damage here again of the barrage. This was in 2001 Bhuj earthquake. Extreme damage was been experienced in Bhuj. Then a giant earthquake and associated tsunami in 2004. This photograph is from KANPUR, where total damage was experienced by the people, and many Indians who got killed in this one. Okay. So, almost like around the Indian Ocean, if you take almost like 2,30,000 to 2,80,000 people in 14 countries were been affected and killed. Actually, this were not they just affected, but they got killed. So, very large number of population was killed because of the giant earthquake in 2004. This is another photograph from the same area, KANPUR. Then 2005 was the Kashmir earthquake. Almost 80,000 people were been killed. Now, I just would like to emphasize here is that the fault which was responsible for triggering this 2005 earthquake, Muzaffarabad earthquake or Kashmir earthquake, this fault was been identified way back in 1999 by Professor Nakata of Hiroshima University. And this person, he extensively worked in Himalayas, and he was the first to give us the nomenclature, or I would say that the name for the frontal fault, that is Himalayan frontal fault. And he gave that how active faults, or the technique how the active faults should be identified. Now, he reported this about the Thanda active fault in Kashmir or in Pakistan, that this is one of the active fault which will trigger an earthquake in near future. A report was been submitted to the Geological Survey of Pakistan, but they mocked on him. They did not bother about his finding, and finally they experienced the same in 2005. Then there was 2011 giant earthquake of Tohoku, magnitude 9.1, and the previous one which we were talking about Kashmir was 7.8 or 6, and then 2004 the Andaman Sumatra was 9.3. So, total damage was experienced in some part of Japan. Okay, almost 19,000 people got killed, and this also will give a lecture talking about that what are the findings from Japan, or the colleagues in Japan which they have done the research in this area. This is again another photograph. Usually in Japan, what they do is to protect the areas, the coastal areas, they try to construct a wall. Okay. And this is the tsunami wall which was been constructed taking into consideration the previous records. Okay. But let me tell you that they were very much aware that they may have a larger tsunami than what they have experienced, or they have noted here, because there was one Jogan tsunami around 1808. I'm not remembering the exact year, but it was 895 AD or so. But we'll talk in detail when I'm talking about the tsunamis or the events from Japan. So they had this understanding, because the research which they did clearly indicated that the next tsunami which they are expecting in this region may be much larger than what they expected. So if you see, this photograph is before the tsunami, and this is after one. Okay, so the water which completely toppled down the wall. So this wall which you see here, now the next slide, what it shows is the water is coming, the tsunami waves have almost toppled down. So you can just have the marker here. One is this board here, another is this house here. Okay, and you can't see the wall because the water is coming above that. Okay, so this was the condition or the situation which Japanese people experienced in 2001 Tohoku earthquake. Coming to the Gorkha and Kodari earthquakes in Nepal, 2 earthquakes took place in this region in 2005. The damage was not so severe, but of course it was bothering for us actually. Okay. So this was the building, one of the school building which collapsed. The columns were broken because of strong ground shaking near Kathmandu, and this was the tower, okay, which collapsed and many people got killed in this one. So almost 10,000 people were killed during this earthquake in Nepal. Now the reason which has been given for the comparatively less or moderate damage is been shown here, that the ground acceleration which one could have expected in a earthquake of magnitude 7.8 or 7.9, where the similar magnitude earthquakes have been listed here: the Imperial Valley earthquake 1940, Loma Petra 1989, Kobe 1995, Northridge earthquake of US in 1994, and then the Nepal one. So in terms of the magnitude, these earthquakes are very much similar. So what we expect is that similar amount of energy was released, but sometime the complex nature of the crust will teach us a different lesson. Okay. So these earthquakes which have been shown here by yellow, green, blue and black lines are very much sitting. So the immediately after the earthquake triggered, the ground acceleration was peaked up here. So very strong ground acceleration, but what happened in terms of the Nepal, it was very slow. Okay. And you can see the graph here is very broad here, and then the ground acceleration which could have been expected as based on these earthquakes was not at all similar. So it was very gentle swing which we experienced. Okay. So the damage was not much because the ground acceleration which was expected was not up to or similar to what was been experienced in previous similar magnitude earthquakes. So this was one of the reason for that, but this will never remains the same. The same magnitude earthquake may have different type of damage and ground shaking. So we are blessed that this event was not similar in terms of the ground acceleration of Northridge, Kobe, Loma Petra and Imperial. So active tectonics further, if we look at The term active tectonics refer to those tectonic processes that deforms the earth crust on a time scale of significance to human society. So, what does this indicate to us is that we are interested at this stage, talking about the paleoseismology and all that, we are interested in understanding the tectonic processes on a time scale which is significant to the human society. We are mostly interested in knowing the processes that were responsible for the disruption of any civilization in a span of several decades or several hundred years, or since the evolution of modern construction. Example, facilities like buildings, dams, power plants, etc. Because these are the lifeline structures which will be damaged or disrupted, or we can say that earthquakes can affect the whole settlements. And in past, there are signatures or the evidence which tells us about the human transfer because of major earthquakes. And let me tell you the example which we have been able to pick up from Kutch region is the Harappan settlement. Based on our studies, we have inferred that there were 2 to 3 major earthquakes during that period, that is almost like 4,000 years back and 2,000 years back. There were major earthquakes which were responsible for the decline of Harappan civilization, and the evidence which we got are related to Dholavira and subsequently from the Great Run of Kutch, close to the Indo-Pak border. So, we will try to focus, when we are focusing on Kutch region, we will try to give one lecture on that part also. So, basically we are interested in understanding the active tectonism, which refers to the tectonic processes significance to the human society, and mostly we are interested in knowing such processes, how they have affected and whether they will be responsible for disrupting any major civilization, or they were responsible or they will be responsible for damaging the buildings and lifeline structures like schools, hospitals, dams, power plants, etc. Now, further, so in order to predict tectonic events over this period, we need to study and understand the tectonic processes over a much longer time scale, because and that time scale could go up to 10,000 years, as I told in the beginning, because that will tell us that what is the pattern of ongoing deformation and will help us in understanding the overall process. Because the recurrence of large or giant earthquakes on a particular fault may be longer. So, if we study a very small span of time, say 100 years, we may end up saying that, oh, there is no earthquake in the future, but there may be an evidence or signature which is sitting in the sediments or the landform, which talks about or tells us about the earthquake which has occurred either 10,000 years or 1,000 years back, or close to 10,000 years back. So, as I told that the 2001 Bhuj earthquake was not expected, and the expectation was not there because we never knew about that what is the past history of that region. But now since we have started studying or doing the research in that particular area, we can say at this stage that the Kutch region has capability to trigger much larger earthquake as compared to what we experienced in 2001. And one of the example, of course, the magnitude has been undersized for 18, 19, 11th earthquake in Great Run of Kutch. But the features which we observed, signatures and the landforms as well as within the sediment succession, it clearly suggests that there are chances of having much larger earthquake as compared to what we had in 2001. And those earthquakes, the paleo earthquakes, the ancient earthquakes, were responsible for decline of the Harappan civilization. So we need to study the much longer record of the earthquakes or the processes to understand the overall tectonic deformation. So further about the active tectonics, an active tectonic process which is likely to produce a catastrophe. This we are talking about the major or great earthquakes. However, moderate size earthquakes also can produce catastrophe, and this is one of the case which we have experienced in the Palu earthquake recently in 2018, that we should not underestimate the moderate earthquakes, particularly if they occur in densely populated areas where buildings are constructed of material that cannot withstand seismic shaking. So even moderate earthquakes with magnitude 5 or 6 will be dangerous if we have the poor construction. So this is one of the point which one should keep in mind. Houses constructed of unreinforced cement blocks, bricks or stones are particularly hazardous, or buildings constructed on thick layers of unconsolid sediments, particularly those sediments with an high water table or high water content. This or such areas will be extremely vulnerable even if you are having moderate magnitude earthquakes. So as I was talking about, we have primary features and we have secondary features. Similarly to that, we have the deformation which is taking place close to the faulting region or seismically active region and away from the such regions. So this is one of the point at the end which we have talked about, that if the construction is on thick alluvium, will be responsible or vulnerable from the earthquakes which are occurring far away from those areas. Okay, I'll stop here. Thank you very much, and we'll continue in the next lecture.